Same, let me take up a question, basically two questions from mensuration where the surface area and the volume of a solid object is considered. Okay, so the first question which I have taken for today is a cubical block is given to you, right, and it is surmounted by a hemisphere, right? This is a question from NCRT. Okay, so what is that? The cubical block is having some side, and what is the side of the cubical block? This is given to you as 7 centimeter. That means the edge is given to you, right? Now after that, it has been asked that, and basically this is the cubical block which is surmounted by a hemisphere. If this is the side view of the cubical block, then it is just surmounted by a hemisphere like this, right? This is surmounted like this. Now there are two shapes which is considered over here. One is what? One is your hemisphere. This is your hemisphere, right? This is your hemisphere, and the cube is here into the bottom. So basically the question is that find the total surface area of the solid. Okay, when the cubical block which is on the bottom and it is surmounted by a hemisphere. My dear friends, if this is a cube, then definitely what will be the edge? It's given to you 7 centimeter. So the first part of the question is that what is the greatest diameter of the hemisphere that can have, right? So my dear friends, what is the greatest diameter that we need to understand? If this is 7, all the sides of a cube are 7, right? So what is the greatest diameter? You can see this is the maximum diameter which is possible, right? The dome or the surmounted hemisphere could not go beyond this, right? Could not go beyond this, right? So what is the maximum diameter? So maximum diameter, we can say max diameter of the dome or of the hemisphere is max dia is 7. What is the whatever will be the edge of the cube, right? Now what is the total surface area? So to calculate the total surface area, we know that all the four faces, the total surface area, TSA, TSA can be calculated as the surface area of cube, right? Surface area of cube altogether, right? Plus surface area of this hemisphere plus surface area of hemisphere, right? Both of these should be added, but one shape is just need to be removed because the shape which is into the contact of the cube, okay, this shape, the bottom shape, the hemisphere, at its bottom there is a circle, okay. So you need to remove this portion, okay. Why? Because this is in contact, this is in contact with the face of the cube, okay. So I'm saying at this point this circle is lying, right? If this is the hemisphere portion and this is the cube, you can see as it's lying, then if you just cut a slice from here, you can see from the and reverse it the hemisphere, you can see the hemisphere bottom is like this, right? You can see it's like this. So we need to remove this portion. Why do we need to remove this portion? Because this is the same portion which is inverted and looking like this, right? And this is in contact, so this will not be considered into the surface area, right? So that's why that area need to be removed, right? And what is that area? Definitely area of this circle. So minus area of the hemisphere base, or you can say circle circle base of circle which is the base of hemisphere, right? You understand this part? Now my dear friends, here we can see what is the surface area of cube. You know, cube is just like a square. Okay, this is just like a square, right? And it's from all side you can see the area of this square is a square, a square, a square, a square. This is coming 6 times, right? So surface area of the cube will be 6 into a square. A, that means the side. What is the side of this cube? 7. So it will be 6 into 7 a square, right? So this is done. This is done. Now surface area of the hemisphere. What is the total surface area of a sphere? It's 4 pi a square, right? You remember. So surface area of the hemisphere will be equal to 4 pi r square divided by 2, which is equal to 2 pi r square, right? And the area of the circle, which is the base of the hemisphere, which we spoke, okay, that need to be removed. So that means minus pi into r square, right? Minus pi into r square. But remember, my dear friends, this 7 is the will act as a diameter. This is the diameter, right? So what will be the radius? Radius will be 7 by 2. So it will be 7 into 6. So 6 into 49 with the surface area of this cube plus 2 pi r square, or you can say pi, when pi and r square is taken as common. What is r? R is 7 by 2 whole square. Then we are left with pi r square is taken as common. Here we are left with 2 minus 1, right? You got it? 2 minus 1. So basically it's pi into r square, right? When you just solve it, you get your answer. 6 in 9 49, 6 54, carry 5, 6 4 24 plus 5 29, 294 here, plus pi is 22 by 7 into 7 by 2 into 7 by 2, because it's r square multiplied with 2 minus 1, which is 1, right? When you just solve it, 7 will be cancelled, 2 will divide this 22 in 11 times, right? So it will be coming as 77 by 2, right? So the final surface area of the given shape is given to you is calculated as 294 plus 77 by 2, which is equal to 24, which is equal to, just solve it, 294 plus 77 by 2. 77, half of 77 is nothing but 38.5. 38 into 2, 76, and 1 will divide it into, so it will be 38.5, right? So when you just add it, you will get your answer, that is 0.5. 8 for 12, carry 1, 3. So it's coming at 332.5 centimeter square, right? And this is your answer, my dear friends, 332.5 centimeter square, right? So my dear friend, this question is solved like this. Okay, what we need to understand, the main thing which I explained this part, okay, which is into the contact, which we are not able to see from the naked eye from outside. So that's that face that need to be eliminated, and this is the face which need to be eliminated, right? On the same concept, there is another question which I have taken for today, that is also from the NCERT, that a hemispherical depression is cut out. Here on the cube, a hemisphere was mounted up, okay, but into the second question what we have considered, okay, let me take it up. Into the second question, it's given that a hemisphere is there, okay, a hemisphere is there, but inside it a hemispherical shape is cut out like this, okay. So this block will be looking like this. Okay, looking like this. So if you just see from the top, if you see from the top, okay, there are two shapes. One is the hemispherical cutout. This is the hemispherical cutout with this portion I am saying, right? This is the hemispherical cutout. That means this is a cubical block. From this hemispherical shape of object is extracted. So what is the total surface area? What is the total surface area of this entire shape? This has been asked. When it's given that, the determine the surface area of the solid which is just left, right? Now if you assume the x as the edge of this cube, if this is a cube, right, which is given into the question, then what is the surface area of the cube? So the total surface area which we need to find out, it will be equal to total surface area will be equal to, into the previous question when there was a hemisphere which was mounted, we have added it, right? But here what we need to do, we need to subtract the hemispherical shape which is been cut out, right? Because that is being removed, right? That is being removed. So the total surface area will be surface area of the cube, surface area of cube, right? This will be minus minus this shape of the shape of the circle which is forming on the top, because this is removed. Okay, so this is removed, so the circle part is removed. I mean to say, if this is the hemispherical dome or hemispherical depth, right, not dome, dome is on the elevation. So you can see this portion, this portion is not lying, this is a hollow. Okay, from this you can just see inside, so this need to be removed. So this area will be equal to pi r square, right, minus pi r square. This is the same area, right, pi r square. Now plus the area, surface area of the hemisphere which is additionally introduced, so that will be equal to plus surface area of hemisphere, consider the full, right? Now surface area of cube is 6 into a square, so this will be equal to 6 into x square, right? Now surface area of hemisphere, so what is the area of this circle, this one, this is equal to pi r square, so this is pi into x by 2 whole square, right? Why pi into x by 2 whole square? Because this is the radius, right? X is the edge. If this is edge, then definitely from here to here you can see only x by 2 will be left, right? So this is your radius, this is equal to radius of this hemisphere. Now plus surface area of the hemisphere, so that will be equal to, the total surface area of the entire sphere is 4 pi r square, so it will be equal to, for the hemisphere it will be equal to 2 pi r square, right? So 2 into pi into x by 2 whole square, right? Now here 2 pi r square minus pi r square, 2 pi r square minus pi r square, so only pi r square is left, right? 2 times pi r square in minus pi times pi r square, r square. So only pi r square is left. So this will be equal to 6x square plus pi x square by 4, right? So this will be equal to what we did. You understand it, right? For these two, we have, you can see 2 times pi r square minus pi r square. So 2 minus 1 is 1. So that's why only 1 pi r square is considered over here. And we get our answer as, when x square is taken as common, then we have 6 plus pi by 4, right? You can just solve it, and this is the total surface area of the, this will be the total surface area of this shape, the total surface area of the shape which is formed, which is formed when an hemispherical cutout or hemispherical depression is cut out from the face of the cubical wooden block, and it was given that the diameter of the hemisphere is equal to the edge of the cube. Okay, and that we have also considered here, right? So in this way we can solve such question, my dear friends. Okay, thank you so much for watching. Take care, happy learning, bye bye, see you into the next class.